This is for Math 245, Statistics class. In this video, I'm going to go over the first, I believe, 13 slides. Yes, slide number 1 to slide number 13, so that I can cover the first learning objective for section 5.4. 5.4, we're still working with normal probability distribution, but it's introducing you something very important called sampling distribution. So let me go ahead and start the Google slide. 5.4, sampling distributions and the central limit theorems, is the last section that I will include in your test 2. 5.5, I will not include that in your test 2. I do have an extra credit MyLab assignment on 5.5, so I'm going to ask you to read section 5.5 and try those homework problems if you would like to get some extra credit. But 5.4, I wanted to go over this together, even though this is part of your asynchronous lesson for our class, because this is pretty important. Okay, this is the important section. So, learning objectives. The first one that I will cover in this section is how to find sampling distributions and verify their probabilities. I will talk about what sampling distribution is, and I'll give you how to find the mean and the standard deviation of this distribution. The second and the third learning objective of section 5.4 are using central limit theorem. I'll come back and record 2 more videos on those 2 learning objectives, but in first video, in this one, we'll talk about sampling distribution. Okay? All right. So what is sampling distribution? It is the probability distribution of a sample statistic that is formed when a random samples of size n are repeatedly taken from a population. So what does this mean? Okay? So here is an example. Okay? Say that I want to know the average GPA of NOVA students. Say that is let's say that NOVA students are my population. And the parameter of interest is average GPA of all NOVA students. I can't really go out and ask every NOVA student what their GPA is. I think I can look, I don't know if I can look that up on SIS, but anyways, if I'm just trying to do this by like survey, I wouldn't be able to find that out from the population. So what I can do is I can take a sample. Say that my classes are about 36, but all right, let's say that I am going to take a sample of size 25. I'm just going to get a sample of 25. I will go to your class and randomly pick 25 students from my statistics class, and I will calculate their GPA. One number GPA will come out, right? And that GPA is called sample statistic from our class, right? Because that is a sample of 25, and statistic refers to the number that describes a characteristic of the sample. But here's the thing. Let's say that I got a GPA of 3.8, okay? Your average came out to be 3.8. And I'm thinking, that sounds a little too high. So I'm going to go and take another sample of 25 from my pre-calculus class. Let's say that I take another sample, same size, 25 students, from my pre-calculus students. Will their GPA be the same as your GPA? Not necessarily, right? Maybe their GPA is 3.9 or 2.5. But sample statistic is going to be different from one sample to another sample because samples are all different. Okay, does that make sense? Like my statistics class is not necessarily exactly the same as my pre-calculus class. So if I collect sample statistic from one group and from another group, I'm going to have different numbers. And those numbers will have an average, and those numbers will have a standard deviation. They will vary. So that's what we are talking about, how samples vary. But I'm going to keep the same size, same sample of size n, and I'll just take that sample or the same size sample repeatedly from a population. And I'll show you a picture of that too. Like my example that I just gave you, average GPA. If the sample statistic is the sample mean, if I am interested in taking average, then this distribution is going to be called sampling distribution of sample mean. We can have another type, for example, sampling distribution of sample proportion, but that's going to be for another section. In this section, we're going to talk about sampling distribution of sample mean or average, how average from different sample varies from another. Okay, so here's a picture for you. Say that we have a population with this unknown average mu, the mean of the population. We use the symbol mu. Okay, for example, the GPA of all NOVA students. Okay, and it also has a standard deviation of lowercase sigma, right? So in this, if you think about this orange box as the population, everybody that I'm interested in knowing about, I can take one sample. And that little random sample one has one X bar, okay? And that X bar means sample average. If I get about 25 students from NOVA, that's a sample of whole NOVA students, right? I can find their average. That average is going to be called X bar, and that little subscript 1 just means that is the sample average from random sample number 1. I can take another sample, sample number 2, and find another average. You see X bar 1 and X bar 2 can be different, right? Because a green group and the yellow groups are two different groups, okay? So their average may be different. I can take another sample of the same size. If I pick 25, that red circle also has 25 students in there, and find their average. That's going to be X bar number 3. And here's one more thing. You see how the yellow and the orange, not the orange, yellow and the pink intersect, right? They can have a common individual. So for example, if I'm taking I do have some students who are in my both pre-calculus class and my statistics and calculus class. If student is taking both, I may be using that student twice, and that's okay. Next, well, that blue group, I can take another sample of 25 students and calculate the average of that 25 student. That's going to give me X bar number 4, and 4 stands for this is my 4th sample. Maybe that's enough. One more, okay? How about that I don't know, mustard color sample? Sample number 5 will give me X bar number 5. You see, if I have 5 different samples, I can have 5 different sample statistics, right? 5 different averages. The sampling distribution consists of the values of the sample mean, X bar 1, X bar 2, X bar 3, all the way up to X bar 5. If I just look at these X bars, that's what we call sampling distribution of sample mean. These are the averages from my sample. I hope this is making sense so far. I got a couple more slides to talk about sampling distribution. Let's talk about the properties of sampling distributions of sample mean. Pretty wordy now, right? Going back to that X bars, guys. Going back to that X bars. If I add up all these X bars together and divide by 5, I'm finding the average of the averages. Does that make sense? I am finding the average of all these 5 different averages. Say that you're doing that for every possible sample. Okay? The mean of the sample means, which we use the symbol, look at the symbol for me, mu with the X bar, mu's of X bar. Mean of the sample means is equal to the population mean, mu. If you take every single sample of that same size and you add up all those samples and divide by the number of samples, what I just described is called mean of the sample means. that equals to the population mean mu. So that part is easy. We're going to just use the population mean. Standard deviation is a little different. Here's a formula for you. The standard deviation of the sample mean, we use the symbol sigma and the x bar as the subscript. Okay, and we read this as standard deviation of the sample means is equal to the population standard deviation sigma divided by the square root of the sample size n. So what you're going to do is this. For some crazy reason, if you know population standard deviation, or if we can estimate to find the standard deviation of the sample mean, we're going to divide that by square root of the sample size. And don't worry, we will look at some examples together, okay? So these are the two formulas. And because you see how wordy this is, it's called the standard deviation of the sample means. So we are going to just call this, from now on, standard error of the mean. Same thing. Let me go ahead and highlight them both. Standard deviation of sample means is the same as standard error of the mean. So they're talking about the same thing, okay? So if you see different wording, don't worry. It's just population standard deviation divided by square root of n. That is what standard error is. All right, slide number 8. Yay, we have an example. Let's look at this together. A number of times 4 people go to grocery shopping in a month is given by population values 1, 3, 5, and 7. So what does this mean? Say, let we have 4 people. Sue, Sue, Michael, Noah, and Luna. So we have these 4 people. Just 4 people. Sue goes to grocery shopping once a month. Michael goes 3 times a month. Noah goes 5 times a month. And Luna goes 7 times a month. That's what they are saying, okay? Just we got 4 people, and we asked those 4 people, hey, how many times do you go grocery shopping? And they gave us these numbers. Small population so that we can demonstrate the sampling distribution, okay? Now, what are we doing with this? They said, create a histogram, probability histogram for the data shown. Okay. And if you take a look, this is relative frequency, right? Because they use the probability. One person goes once a month. Another person goes 3 times a month. Third person goes 5 times a month. And the last person goes 7 times a month. So we have 25%, 25%, 25%, and 25% chance. If I randomly pick one person from this group, there is 25% chance that they go grocery shopping 5 times a month, 7 times a month, 1 or 3 times a month. Okay, so they just have a probability histogram for this data, this population value. Okay, so what are we doing? That's not a sampling distribution just yet. We're just describing the population for right now, right? Let's go to the next slide to see if we get to talk about sampling distribution. All right, so that's the population distribution, which is a uniform distribution, as you can see. Say that you randomly choose 2 of the 4 people with replacement. Okay, so what I mean is this. So out of these 4 people, I'm going to randomly pick one person. Say that I pick Michael. And then I'm going to pick one more person. Say that I pick Luna. So my sample consists of Michael and Luna. That's one sample. But when they said the word replacement, that means, say that I'm doing another sample. I picked Sue. I picked Sue back in the same in my population, and I pick another person, and it happens to be Sue again. So there is a chance that Sue shows up twice. So that's what replacement means. So out of 4 people, we are going to randomly pick 2 people. We're going to list all possible sample sizes of size n equals 2 and calculate the mean of each. Okay, so if I pick 2 people, and those 2 people have number 1 and 3, then the average will be 1 plus 3 divided by 2. If I pick 2 people and one person goes 5 times a day, a week, a month, and another person goes 7 times a month, I will have to add a 5 plus 7 and divide by 2. Does that make sense what we are doing? We're going to randomly pick 2 people, and find their average. These means, these averages that we're calculating from the sampling distribution of the sample, okay. And they said find mean, variance, and standard deviation of the sample means. Okay, it's going to be a lot, even though we only have 4 people. If we try to list all possible sample, it's going to be a lot. All right. And they want us to compare the result with these 2. Now, look at the symbol for me, because symbols make big difference in statistics class. They said mu equals 4, which means the population average is 4. If you add 1 plus 3 plus 5 plus 7 and divide by 4, we can say on average, these 4 people will go grocery shopping 4 times a month. That's the average. And the variance comes out to be 5, and we know how to do that using the formula, but we're just going to use this because they gave this to us. The standard deviation of the population is 2.2 of the population, okay? I wish they use a different sample. Standard deviation, what is that? I may have to change that a little bit. But standard deviation of this population is 2.2. So let's go ahead and list all possible samples from these 4 people. Look at all these 16 different possible samples. I can pick 1, 1, 1, 3, 1, 5, 1, 7, or I can do 3, 1, 3, 3, 3, 5, 3, 7, and so on. And the last sample that I can, listed is 7 and 7. I'm glad they already did the math for us. And then what they did was they added these numbers and divided by 2. Like for example, 1 plus 5 is 6, divided by 2 is 3. So what they did was they found multiple sample means. We have 16 different X bars. Do you see that? From 16 different samples of size 2, we have 16 different sample averages. Now what we're going to do is we're going to look at these X bars. X bars range from 1, 2, 3, 4, 2, 3, 4, 5, all the way to 7. Okay? If we construct a probability distribution of these sample averages, and how did they do this? Take a look, guys. If you look at the X bar, there is only 1. X bar equals 1 appeared only once. But if you notice, I think a common X bar, I think it could be 4. How many 4s appeared? There's 1, 2, 3, 4 4s appeared. How many 5s appeared? 1, 2, 3 5s appeared. So what they did was they organized this in a table. They created a probability distribution. So how many times X bar of 6 appeared? It looks like twice, which means 2 out of 16 for the total. So they created this probability distribution, and when you create a histogram, you notice how the sampling distribution of sample mean is not really the same shape as the population distribution. You notice how the population distribution was a uniform. The boxes or the bars have the same height. But if we did the sampling distribution, you notice how this is actually more like a symmetric distribution, isn't it? Okay? So how about we find their mean? What do you think the mean of this graph, okay, this probability distribution? The average of this perfectly symmetric distribution is probably this bar in the middle, the 4. So what we can see is that the probability distribution of sampling distribution of this x bars has a mean of 4. And how would we find the standard deviation? Let's take a look. Next slide probably has it all. Okay. The mean is 4. As you saw on that histogram, the average of these averages are 4 or is 4. So the mean of the sample means is 4. Now for the standard deviation, what is this? I don't like how they're using the... Oh, no, I'm sorry. I'm very sorry. They actually found the variance and the standard deviation by looking at this probability distribution, probably this table right here. But I want to use the formula that we talked about in slide number 7. Okay, slide number 7. Slide number 7 said standard deviation of the sample means is population standard deviation divided by square root of n, right? So what I can do is, let me open up my Word doc, okay? And I will go ahead and do that standard deviation with you. So can I call this standard, hold on, let me make this a little bit big so that I can type it. Maybe I will insert math equation. Standard error I'm sorry, I'm just using one hand right now, so it's hard, is equal to, I need to put population standard deviation on top of this fraction. And they gave that to us, which was on this slide 2.2. It was 2.2. So I'm going to put that on top of the fraction, as you can see on this formula. 2.2 goes on top of the fraction. The bottom of the fraction has to be square root of n. N is the sample size. What was the sample size? Sample size was 2. So the bottom of the fraction, I will put square root of 2. And all I need to do is evaluate this. This is going to be approximately, I need a calculator. I'm going to go to Desmo Scientific Calculator real quick. Desmo Scientific. I need a scientific calculator. I will do 2.2 divided by square root of 2. As you can see, when I type that in, the standard error comes out to be 1.56, rounded up. 1.56. So that is how you can find the standard error, okay? So let me go back and see, check the slide again to see if they got the matching answer. 1.56 is my answer. So over here, and I used the formula. What they did was they probably actually found the variance in standard deviation using this data. But it should be the same. 1.6. I did 1.56. So it's just a rounding difference. So, but they were the same thing. And I think slide number 13 is going to use the formula, what I just did. So let's go over this. So mean is the same as the population mean. So mean of the sampling distribution of sample mean is equal to the mu, which is 4. And the second one that they are going to do is, I hate how they wrote it. Yeah, but it's the same thing. I put 2.2, which is square root of 5 on the, well, I guess this is pretty accurate. The square root of 5 was 2.2, what I used. Okay, so if you want to just see, if you want to double check if I'm telling you the truth, square root of 5 is, I guess 2.23. So why did they give me 2.2 over here? I'm gonna go ahead and fix this. We'll go back over here and fix this. I'll just say square root of, yeah, see, that's why I used 2.2. But it was more like 2. Well, it is 2.2. It's I'm sorry. I thought I was looking at 6 and I thought it had to be rounded up to 2.3. 2.24, which is still 2.2. So they did give me the right answer. But the reason that I was confused a little bit was because when they gave me the decimal, in this slide right here, they went back to the square root notation. So I may just keep it as square root of 5, because I know some of you will just go through the Google slide instead of watching this. So I'll just keep it as square root of 5 divided by square root of 2. That's how you can find the standard deviation or the standard error of sampling distribution of sample means. We do want to solve some problems that's using this, because look, well, I guess I can't really talk about it just yet until we know why we can use normal distribution. So please come back if you have time to watch the second video on the central limit theorem. I've been going for about 27 minutes, so I will stop this recording because I did finish the first learning objective, which talked about what sampling distribution is and the property. How do you find the mean? And how do you find the standard deviation of sampling distribution? So I will go ahead and pause this video on YouTube now and post this on Canvas for you. And we'll come back sometime later to go over the central limit theorem.